Hi, thanks for watching the video. My name is Chris Anderson. I'm an engineer on the Windows UI team working on some new experimental frameworks features going forward. And I want to talk about kind of some of the stuff that we've been working on uh, behind the scenes and really trying to move this to be a more of in the public. So welcome. First, I really want to spend the time before I dive into new and exciting things that I think are, you know, kind of attractive and shiny baubles on the in the future. I want to talk about kind of like the stuff that we need to get going so that we can like earn the right to build some of these things. And this is really, the core features that people have been asking for and really kind of like need to be productive on top of WinUI. The first and foremost is like performance, fundamentals, quality, fixing a lot of bugs. On the performance side, we've invested heavily in really improving memory usage as well as switching over to a system compositor, which should yield some even better performance improvements. And this stuff is all actually hit the public in our Git repo. And so it should be available to go play with today. And there'll be WinApp SDK versions that incorporate these changes available shortly through the experimental and preview branches. We're also adding in a lot of new controls. We have DataGrid and charting that are up and coming that should be out relatively shortly. These will be showing up in the core WinUI bits and will allow you to go after a lot more of these data-oriented scenarios. One of the big things that I'm personally really excited about is for us to complete our journey to open source. We've started on this path quite a while ago. We recently hit our phase 3, which was when we could actually run tests in public. And so anyone can grab the bits, compile WinUI, and then run the test to make sure that they have something that is fully functional. If they want to make changes, they can run the test and make sure they haven't broken anything, which is an important part of having an open source library. The big next phase for us is phase 4. And really that is where we move the team from using internal source repos to working primarily and almost exclusively in the public repos. And so you'll see the team start to land all of their pull requests in the public repo side of it. And that's really just about getting to kind of a place where we can accept changes from the community, we can engage in the community, and the community can see the work instantly as soon as we've got it going. With these changes, we've really heard a common set of themes. Probably the number one thing is are you guys actually serious this time? Are you going to stick with this framework? WinUI is, WinUI 3 is 4 years old. Are you going to keep going, or is this the year that you're going to announce a brand new framework yet again? And I will say that no, we have no intention of building a new framework. In fact, we're kind of dropping the number and we're referring to WinUI as just WinUI because we have no intention of really kind of making a massive shift, breaking change on it. And we're really trying to push hard to stretch WinUI to be accessible for any use case that we want. We've started to integrate it into the shell at a much faster rate. And so you're going to see a lot of the first-party features coming from Microsoft being built on top of WinUI, and we hope to see a lot of third-party developers start to really start to adapt it. We've seen some pick up already, but we know that the move to adopt a new UI framework can take a long time, especially in enterprise spaces. And so we are kind of, we see this as our time to really start showing that we are putting our muscle behind this and that we're committed to move WinUI forward, and that is fully our intention. The second thing we've heard a lot is beyond DataGrid and charting, there's just a ton of feature gaps in the platform. Everything from, what are you doing about system tray? And you have limited use of Windows. A bunch of people use open source libraries to fix these gaps. And, can we just get the platform fixed? And so we have a large backlog. We're going to start working through that and really start trying to address the feature gaps that people are calling out. But it's been one of the biggest issues. The third thing that is a constant source that people bring up is how are we going to migrate? How are we going to go from the current set of frameworks we have? Can we just incrementally adopt WinUI, or are you making it an all or nothing proposition where you have to rewrite everything? We have a reasonable story of WinForms interop today. It's not great, but it's a reasonable story. It works pretty well. But we want to build on that. We want to make it that should be a bulletproof part of the story. That WinForms interrupting with WinUI in either direction should be just super easy to do. So we intend to do that. We want to make WPF migration equally good, that you should be able to mix and match WPF and WinUI with no problems. And so that's a big chunk of work that we want to get to in the future. What we've also seen is that the development style is changing quite a bit. The AI assistant has changed the way people write software. It's changed the way I write software. I rarely type semicolons anymore. I'm almost always using AI to drive most of the code that I'm writing. I use it for code reviews, for writing tests. I have it help me with specs. And so like this whole notion of this AI shift has really, really transformed the way you write all the code. At the same time, we've seen this journey of more and more dynamic UI continue. It accelerated in a lot of ways, and I look at things like SwiftUI, Compose, and React as examples of kind of the best practices in the industry today for building these dynamic UI, and it becomes super straightforward to build things that are incredibly flexible and responsive to what the user does. And so, like, that's another trend that we really see. And the second one is really this notion of getting to kind of code as the primary way to write things. On one way, you can say that this move to CLI based coding tools with Cloud Code, GitHub Copilot, things like this have led to Visual Studio Code becoming like one of the most productive places to be to work on your project with your terminal window next to you. And this really gets to a world where code first becomes kind of the de facto standard. And so what we really want to do is get C# as a primary way to target WinUI. We want to take, elevate C# from being a way to do code behind for XAML to a way that you can actually write an entire application. So you should be able to build a existing, WinUI framework, use the controls, the templates, all of those features should be accessible from a C# first experience. Several of those are currently locked behind needing to have XAML. And so we really want to bring C# up to parity. We're also announcing today a new experimental framework, which is called Reactor. Microsoft UI Reactor is a way for us to experiment with new styles of programming, new controls, and kind of new app models as we think about it. The Reactor repository you should think of as a place for us to experiment with ideas that we don't necessarily have full conviction behind, and that we really want to engage with the community and do development out in the open. And so it was started as an open project. It is very early. It is high churn rate. We're changing, lots of the code on a daily basis. So you should really think of this as a place that is open for a ton of feedback, a ton of guidance from the community, a ton of participation from the community. We already have PRs landing from some of the community, and we would like to get more. And the idea is that as we find good ideas and as we bake those ideas, we'll be pushing them down into the production WinUI bits, and that they will at that point become consistent and standard across the WinUI stack so that it doesn't stand out. So you may see things that look kind of foreign in the Reactor layer, and really we shouldn't, don't panic about that stuff. It is a place for us to try these ideas out and then see which of these make sense to go get pushed in. So really the main action I would say for people watching this video today is please pick up WinUI, go build something with it, keep using it, keep making it forward. We have no plans on deviating off that as our primary way of moving forward. We're investing in it. We hope that you will too. And then the last thing is let's go try out Reactor. Give us feedback. Start, go clone the repo and try it out. Let's start by diving in and showing you what's in the new Reactor repo, and let me show you that. Let's dive right into Microsoft UI Reactor, which is a new open source project that we're releasing that shows the future direction that we're thinking of for WinUI. It includes a bunch of controls that are experiences that we think are going to be delivered as part of the core WinUI bits using the XAML you know and love, data binding, the MVVM architecture, all the features you're looking for. As well, there's included in the project a new kind of domain-specific language or a new projection into C# for all of the WinUI controls that are out there. And this allows you to use C# as your primary programming experience if you're the kind of person who would like to do kind of a more functional, reactive style approach, as opposed to kind of a XAML-based approach. The library itself, if you go look at the open source project, you'll find that almost everything in there is written using this new C# style. That's mostly because we wanted to experiment with this new style of programming as we built these controls to see what it felt like and where the edges were of it. We don't really expect that this is going to be the right way to build most of these controls. A lot of them are going to be integrated directly into WinUI. They'll be written in C++ using the same WinRT frameworks that you're familiar with. This is just more of a way for us to experiment and learn. And so we, don't take that, just because you see a DataGrid that's in there that's written using this Reactor style syntax doesn't mean that's how we're going to eventually ship the DataGrid. This is more of just an experimental playground. There's a good time to give this context on what I mean by experimental. This is a place where we are likely to change every line of code in this project. We are very early. We want to do the development out in the open, which means that we're going to change a lot of things. We're going to change the syntax. The current syntax is using this kind of fluent functional style expression, but that may completely change. We're working with the C# team about the right way to express these kinds of construction patterns, and we really want to do it in a way that feels very natural in the language. And so we're going to iterate. We're going to change a lot of stuff. Now is really a chance for you to kind of play with the team in the project and take a look. We've already had some contributors from outside of the company who've added some new features to the product and have given a lot of feedback, have issued some PRs. So we're really looking forward to kind of collaborating with the community on all of this. So let's dive in and look at the code and how this functions. So we see here we have a Reactor app run, which is just starting up the project, creates a window. The DevTools flag, we'll talk about it a little bit. It's something that you'd normally only put in a debug build of your product. And then here we have a component, which is kind of the main unit of composition. And we override render, create a title bar, heading, text block, put it in a flex column. And that's what you see over here on the left. So the first thing I'm going to say is that the text block is kind of hard to see. So let's just make the font size larger. We'll save. And then we're going to come over here and we'll create a flex column because I want to kind of take this header and hello text and kind of indent them a little bit. So I'm going to just say margin of 24. And then I also want to have it occupy all the space. So I'm going to say grow 1 and basis 0. So we'll save that. And we see that the app is updating. Down here on the bottom left, I'm just running a normal standard .NET watch command, and up in the left is the app running. At some point, this might crash. It turns out hot reload, not always the most stable. We will see how this goes. But in the meantime, we can just continue to iterate. So we can see basically hot reload's working. We can create our functions. We have a nesting. In this case, we can do, kind of imperative construction. We can also do more of your expression-based construction. Whatever you'd like to do, it's your place to play. Let's make this interactive though. So let's create some state. So we'll say we want a count state. I'll make it be 0, and then we'll just have a name. Feels like what you need to do, and we'll just say name. And then we'll go update our text here. Oops. And we'll just use the name, and then we'll say count. Great. So we see it updates. We got the name and the text. And like you see, as you'd expect, you can do any C# function you want in here. Let's make this interactive. So the first thing we'll do is we'll add a name field. And we'll just say it takes the name and it sets the name. And then we'll have a row of buttons. And we'll just have a flex row, and we'll create a button that says minus. And for that, we'll just say set count to count -1. And then we'll have a button plus, and we'll do set count +1. Great. I can type today. And then last, I want to just put some space. So I'll say with column gap of 4. Great. And let's add these into our header here. So we'll have it be the name field, and then we'll have the buttons. Save. We've got our name field. The buttons are, that's a little weird, but we'll just type in the buttons. So we can type in the name field now. And if I click plus, we see that the count updates. Perfect. We'll get that little layout glitch there fixed in just a second here. Let's continue. So we have basic state, single state. Let's do a little richer one. Let's do collection. So we'll just say I want a numeral that is range to 100. And we'll say, let's just take the index and we'll create another string. We'll just say item hash I, and we'll do a gwid.newgwid.toString and grab 8 characters of it, and we'll make that into a list. Great. If we want to visualize this, let's create a list view. And we're going to take the items we just created. We need to create a key selector. So we're just going to say, because all of our items are unique strings, pretty easy. We can do that. Oh, I have a little typo here. Let's go fix that. And then we need to create a view builder, which is just how we want to create it. So we'll say item. We don't need a second argument, and we'll create a text block with the item in it and a margin of 8 all around it. And last, just because I don't want to have it animate too much, we'll put that in here, and we'll add our list item to our list view here. And because we're putting it in a flex grid, I want to have this guy be the largest piece. So it's going to fix that little glitch we saw earlier also, because that'll consume the rest of space. So now we see our list of items. They're in a list box. They scroll, and we click plus. Everything works. But the first thing you should notice is that when I click plus, all of these become new grids. That's because this render method is being called every frame. Every time you make a change, it's being called. It's recomputing the display, and then we're diffing between the two things, so we only update the things that are actually changed. And in this case, we're rerunning this every time. So these state variables, because we did useState, they stick around. And so here we'll do a use reducer, which is kind of the name for the thing that we do that is a collection valued. And now we'll go in here and say we want items and update items. And so this is how we'll be able to mutate this. And if we save this, we'll notice right away it fixes the bug. We can increment and decrement. We can change our text, and these are no longer recomputing on every frame. Great. Quite an improvement. Let's go and actually update it so we can add something to that list. So add an add method, add button, and we'll say what we want to do is update items. And this, you take in a list, you return a list. And so it's going to be the list that's coming in is going to be called list, and it will say, well, what we want to return is a new list, and the first item we'll have is new item hash, and we'll do list.count +1, and then I won't bother with the GUID, and then we'll just give the rest of the list here. We've got our basic thing. We'll save that, and now if we come over here and click add, we see we can add the new items at the top. Everything still functions. One thing I'd like to show, I want to kind of demonstrate. I've been talking about this diffing thing and this incremental update, and so let's go take a look at that. So I mentioned before we had this DevTools idea, and so the idea is that we think we hypothesized that there is a case to have some more kind of developer-friendly things built into the framework. And so here what I'm going to do is I'm going to turn in and say, I want to have this DevTools menu show up. Now, this DevTools menu actually is automatically conditional on you having set this DevTools property that you wanted to opt into this, and then on the command line that you actually specified you'd like to run this specific instance with these on. And this lets you like turn on developer features in your product so you can debug it better, you can use things, and you can just write conditional code pretty trivially. We have a couple of features built in. So here I'm going to say highlight reconciler changers. And now when I click plus, you'll see that it shows that, oh, we're just updating this string because that's one big string. And if I click the text, you can see we also are updating the text box as we do it. And so really, this is just a way to visualize what is changing each frame. And so what I'd like to do is like demonstrate what happens with a list like this. So let's go into our list. And instead of just doing a text block, let's do a flex row. And we'll put a second thing, which is another text block that says count. And we'll do the same margin of 8. Great. And so now we saw a big red thing because it got re-rendered completely, like new elements created. But now when we click plus, you'll see all we're doing is changing that portion. But this top one, we're changing the whole thing. And that's because this is one text block that says hello, and it does a big string. And so we have to update that whole string. That's an atomic thing. But here we were able to update only the count part because that was a separate element, and we're able to do incremental updates to that element. Great. Let's turn off the flashy blinky. Great. So the next thing I'd like to touch on is how to build new components. So here we have this flex row. The easiest way to build a new component is I can just simply extract a method, and we'll call this list item view. And it turns out that's all we had to do. Like, this is a new function. This is a new component. We don't have to do anything else. It just works. And so we're able to add, in fact, if I change this and say, like, actually I want this to say countish, and we save it, sometimes you get a crash. As promised, the .NET Watch is not always 1000% reliable. Great. While we're waiting for that to load, let's go through and do the next thing that we could create here. So instead of just creating a, we'll just go make a quick change here to force the reload. So instead of just creating a function, you can also create a full component. And so the component gives you a life cycle. It lets you know when when the component is mounted into the tree. There's an update method you can override. And so if I want to create a new component from scratch, it's a little more work than just a function. And so what I'll do here is I'll create list item view. I'll delete this version, and we see that we have, a class that derives from component. It declares what properties it takes, in this case, an item and a count. It has, roughly the same, content that was in there. And then we have a little helper method, that gives you the convenient function call of just calling it list item view instead of having to do a bunch of construction. And so what I'll do is I'll come up here and I'll add using static components. And so now I can simply, this list item view is now binding to that. And so if I save, it's still working, no real change. We think. All right. We'll try to get that going again. Great. Beyond the list view, I want to show one of these new controls. We talked about new controls that we're thinking of adding to the platform that we're looking at that we want feedback on. And so let's go replace this list view with something a little richer. And so what I'll do is I'm going to go and replace this with a we'll replace this with a pie chart. And pie chart takes in the list of data that you want, in this case, items, and then you have to provide it with a way to get a function for the individual component. So I need to get the value, so we'll say D, and we're just going to return 1, so everything is a unit 1 thing. And then I will just say I'd like to have, let's see if this refreshes. Come on. Oh, I have to have code that compiles for it to work. There we go. So probably a few things. Let's just take the first 5. That's better. But what I'd like to do is have a label on these things. And so we'll say the label view that I'd like to use is taking a item. Oops, a little too much noise in there. And we'll just return list item view of that item and the count property. And so now we see our counts. And in fact, if we plus, we see that they increment as they should. Those are a little hard to see. So let's go in here and just say, we can do a little offset. So we'll say list label radius offset and make it be 30. And we see, okay, great, they're out there. But actually, let's do this. Let's make this be 15 times count. And now as we plus and minus the count, those labels move. So you can see this system is really giving this a lot of flexibility of what you can do, how you can transform the code, and that the UI just kind of continues to update and keep up with it. But so far, everything we've shown is synchronous code, which works really well. But what I'd like to do is kind of see what this looks like if we get asynchronous code. And so here what I have is a resource, which is an asynchronous value, and I've just hard-coded it. At the moment, it's just delay for 2 seconds, and then randomly every 20%, let's just have it pretend that it fails, just because that's what the network does. This guy had a little different code in what it wants to show, so we'll leave that so we can see it. And we see if we compile, it doesn't work right now. So we got it. First off, we can't update this item because it's now a asynchronous thing coming in. And then last, you'll see is that this isn't even a list yet. It says there is no take on this. And so what we need to do is get the data out of that asynchronous result. So we'll say items.match. We're going to return an element, and we can basically set what element do we want for different states. So for loading, we're going to have it return a text block that says loading. And if we get into an error state, we'll ignore the error for now and say, show me a text block that says error. And we'll make that be red. And then the last one we can do is what happens if we actually get the data we wanted? Hey, that'd be great. And so we'll say that that takes something which we'll call data. And now we can use our function down here, and we'll say data. And now if we save, we see it says loading briefly, goes into an error state. So what I want to do is have it that I can like kick this and have it try again, because we lost the race. So what I'll do is I'll say, hey, whenever name changes, pretend that's a dependency of this resource. And so now I can come in here, and if I change the name, it goes to loading, and we won the lottery this time, and so we get to see the value. So you can see that what we've built in is easy to use asynchronous functions that can allow you to handle the normal cases you see in UI. Be able to very easily show loading states, error states. You can do this with any asynchronous values. You can have lists that return these, etc. So we've now seen the breadth of kind of the main core pieces of what's in Microsoft UI Reactor. It's an experimental framework. We have a new set of controls, which, like charting would be something that's just generally in WinUI. It's not going to be specific to the Reactor syntax. Very few things would ever be specific to the Reactor syntax. But we can play with this new way of doing C# first development and see how it feels, see what it looks like. Please go try out the repo, clone it, build something with it, send feedback, file feedback items, issue a PR. Let's go see what we can do with this and see if this is something that is interesting to the community, and learn together. Thank you.